Welcome to Talk Tensors. Today we're diving deep into a really fascinating new academic paper.
Oh, yeah. What's it about?
It tackles a really key challenge in machine learning right now. Basically, how can we get these smaller, more resource-friendly language models to perform way better?
Okay, that's definitely a hot topic. How do they do it?
By having them cleverly collaborate with their larger counterparts. The paper's called G-Boost, boosting private SLMs with general LLMs.
G-Boost. Okay,
Yeah.
interesting title. So, boosting small language models with general large language models.
Exactly. And it introduces a pretty innovative way to handle this.
Right. This sounds like something a lot of folks listening might be dealing with. You've got your specific, maybe private data, and probably limited computing power, right? So you fine-tune a smaller open source model, an SLM.
Yeah, makes sense.
And these SLMs, they can get really good in their niche domain. Sometimes, honestly, better than a big general LLM on that specific task.
But they hit a ceiling, right?
Exactly. Their size limits, their, let's say, general world knowledge and reasoning ability.
So this paper explores bridging that gap.
Precisely. How to intelligently combine the strengths of both model types. And crucially, keeping data private and inference costs down.
That privacy angle is huge. And the cost, obviously.
Absolutely.
So this G-Boost framework, what's the core idea?
Well, imagine your private domain-tuned SLM working with a general LLM while it's generating an answer in real time.
Okay, so not just asking both and picking one.
No, it's more dynamic, like a collaboration guided step-by-step. And the guide is something they call a process reward.
A process reward. Okay, tell me more about that.
Think of it like an internal referee,
Yeah.
checking how logical and relevant each step of the reasoning is as the models work together.
Like quality control during the thinking process.
Kind of, yeah. It helps steer the collaboration effectively.
Yeah.
And this is super relevant if you're facing, crazy costs of training huge models, or if privacy rules mean you just can't send all your data out to some external service.
Got it.
Hmm.
And it's not just about saving money or data, is it? It's also about performance.
Definitely. Your private SLM might be great at, say, finding specific terms in legal docs,
Right.
but maybe it struggles to synthesize information across multiple documents or understand really complex arguments that need broader context.
So the LLM brings that broader reasoning.
That's the idea. G-Boost aims to leverage that general capability to boost the SLM on its own domain tasks. It could be a real game changer.
Okay, so to really get why G-Boost is a step forward, maybe we should quickly touch on what came before, like the history here.
Good idea. Yeah, this whole concept of small and large models working together, collaborative inference, has been gaining steam.
Trying to get the best of both worlds, efficiency and performance.
Exactly. People have tried different things, like query-level routing deciding upfront whether the small or large model gets the whole question,
Okay,
or token-level routing sending only the tricky bits to the big model.
a bit more granular.
Yeah. And then there's cascaded inference. Maybe the LLM drafts something, and the SLM refines it for the specific domain.
Right. But what's the catch with those?
Well, a key thing, and something G-Boost really tackles, is that these earlier methods often just assume the big LLM is always better.
Which isn't always true, especially in a niche area.
Precisely. Your fine-tuned SLM might actually know more about your specific data or domain than the general LLM. G-Boost is designed to handle that situation.
Okay. And I guess there's also research on getting multiple big LLMs to work together.
Yeah, that's another angle. Multi-LLM collaboration, often for broad cross-domain stuff like routing parts of a problem to different specialized LLMs or combining their outputs.
But that's not really about boosting one specific private SLM, is it?
Not directly, no. It's a different goal. More about general problem solving with a team of experts.
Gotcha. And you mentioned process reward models earlier. PRMs.
Right, PRMs.
Yeah.
That's a more recent development. The idea is to evaluate the steps in the reasoning, not just the final answer.
So how good with the logic along the way?
Exactly. The consistency, the quality of the intermediate thinking gives much deeper feedback.
Yeah.
And as we'll see, it's absolutely central to how G-Boost works.
Okay, cool. So let's get into the G-Boost framework itself. How does it actually function? Lay out the scenario for us.
All right. So imagine you've got a task.
Yeah.
Maybe analyzing customer feedback for, I don't know, a specific software product you make.
Okay.
You've fine-tuned an open source SLM on your company's past feedback data. It's running locally, maybe on an edge device or your own server. It's great at spotting sentiment, common bugs reported, that kind of thing.
Your private domain adapted SLM.
Exactly.
Yeah.
But maybe it's not so good at comparing your product to competitors based on feedback trends or writing sophisticated summaries. It lacks that broader context.
Right.
But you also have access, maybe via API, maybe locally too, to a general LLM, one of the big ones. Great language skills, good in-context learning, but doesn't know the specifics of your product feedback history.
Lacks the domain depth.
Right. So GBoost aims to let these two collaborate adaptively during inference to nail that customer feedback analysis task better than either could alone.
Okay, adaptive collaboration. How do they model that?
They frame the whole reasoning process as a tree search problem.
A tree search, like exploring different paths.
Yeah, think of each node in the tree as a step in the reasoning, and each branch represents a choice. Does the private SLM generate the next step alone?
Leveraging its specific knowledge.
Or does it collaborate with the general LLM for that step?
Drawing on the broader capabilities.
Exactly. And the goal is to find the best path through this tree, the sequence of solo and collaborative steps that leads to the best final answer for your task.
Okay, that makes sense conceptually, but how do you search that tree efficiently? It sounds like it could get huge.
Good question. They use Monte Carlo tree search, MCTS.
MCTS. Using game AI like AlphaGo, right?
The very same. It's smart about exploring. It doesn't just search randomly. It balances exploring new, untried paths
Exploration.
with exploiting paths that have already seemed promising in earlier searches.
Exploitation. Okay, but how does MCTS know which paths are promising?
That's the crucial role of the process reward model, the PRM we mentioned.
The guide.
Precisely. After a potential reasoning step is generated, either solo or collaboratively, the PRM evaluates that step for logical consistency and relevance to the task.
Not waiting for the final answer.
No, intermediate feedback. That reward signal from the PRM guides the MCTS, telling it which branches of the reasoning tree are worth exploring further.
Very clever. So it directs the search towards effective collaboration strategies?
That's the core mechanism.
Okay, can we break down the MCTS cycle in GBoost? What are the steps?
Sure. Each iteration basically has 4 stages. First is selection.
Picking where to explore next.
Right. Using an algorithm called UCT upper confidence bounds applied to trees. It mathematically balances that exploration-exploitation trade-off to pick the most promising node in the current tree to expand from.
Got it. Balances digging deeper versus looking around. What's next?
Expansion. Once a node is selected, you generate a new reasoning step, a child node. And this can happen in one of 2 modes.
The solo SLM or the collaboration?
Exactly. Mode 1 is SLM, LLM, collaborative inference. This is where the GBoost magic really is.
How does that work technically?
They use a technique inspired by something called proxy-tuning. Basically, they take the general LLM's predictions for the next token.
It's raw output probabilities.
And they refine or sort of nudge those probabilities using information from your fine-tuned private SLM and even its original base version.
So incorporating the SLM's domain knowledge into the LLM's generation.
Pretty much. It's like giving the LLM domain-specific guidance. This fused information creates a new probability distribution to pick the next token for the reasoning step.
Okay, that's the collaborative option. What's the other expansion mode?
Mode 2 is just private SLM inference. Sometimes, the general LLM might just be unhelpful or even wrong in a very specific context where it lacks knowledge.
Right, it might hallucinate or get confused by domain jargon.
Exactly. So GBoost allows the private SLM to just generate the next step on its own, using only its fine-tuned expertise. It adds robustness.
Makes sense. So you select, you expand, either collaboratively or solo. What's step 3?
Evaluation. And here's where GBoost differs from, say, standard MCTS in games. Instead of simulating all the way to the end, a rollout, they use the PRM.
The process reward model again.
Yep. The PRM directly assesses the quality of the single newly generated reasoning step. Is it logical? Is it relevant? It assigns a reward value right then and there.
Immediate feedback on the step quality.
Exactly. They mentioned using an open source PRM called MATH Shepherd in their experiments for this.
Okay. And the final step.
Backpropagation. That reward value from the PRM for the new step gets passed back up the tree to its parent nodes, all the way to the root.
Updating the scores along that path.
Right. It updates the estimated value of taking that path and how many times it's been visited. Over many MCTS iterations, this reinforces good reasoning paths and discourages bad ones. It helps the system learn the best collaborative strategies.
Okay, that whole cycle, select, expand, evaluate, backpropagate, makes a lot of sense. How did they test this?
They used mathematical reasoning tasks, which are pretty challenging benchmarks, specifically GSM8K.
grade school math word problems.
Right. And Math 500, which is high school level math problems.
Tougher stuff. And they needed a data set to fine-tune the SLMs.
Yeah, they use MetaMath QA for that initial fine-tuning step to give the SLM some math domain knowledge.
And which models did they actually use? The SLM-LLM pairs.
They tested two pairs. First, a Qwen 1.5 billion parameter model as the SLM.
Okay, fairly small.
Paired with a Qwen 2.5 14 billion parameter LLM.
Big size LLM.
Second pair was Tiny Llama 1 billion.
Even smaller SLM.
Paired with LMA2 13 billion.
Okay, similar size LLM again. And importantly,
crucially, they used the pre-trained versions of the larger LLMs for the collaboration part.
Why pre-trained?
To avoid data leakage. If the LLM had also been fine-tuned on MetaMath QA, it wouldn't be a fair test of collaboration with a general model. It would already have the specific domain knowledge.
Ah, good point. Ensures the LLM is bringing general reasoning, not task-specific training. And they use that Math Shepherd PRM we talked about.
Yep, that was their reward function during the MCTS.
And how did they compare GBoost? What were the baselines?
They compared it against several things. The basic pre-trained SLM, just out of the box.
This baseline 0.
Then the SLM after being fine-tuned on MetaMath QA.
The domain-adapted SLM alone.
Then that fine-tuned SLM guided by MCTS, but without any collaboration from the LLM. So MCTS helping the SLM reason better on its own. They called this tuned MCTS.
Okay, testing the benefit of MCTS itself.
And finally, they compared it against a static collaboration method, that proxy tuning technique used without the adaptive MCTS framework.
Got it. So isolating the benefit of the adaptive MCTS PRM guidance in GBoost, what were the results?
The results were pretty compelling, actually. GBoost consistently beat all the baselines.
Across both math datasets and both model pairs.
Yes. It outperformed the fine-tuned SLMs on their own, and importantly, it also outperformed the tuned MCTS baseline.
Meaning the collaboration with the LLM, guided by MCTS and PRM, really added value beyond just having the SLM reason better alone.
Exactly. And it also significantly beat the static proxy tuning method.
Suggesting the adaptive nature, the ability to choose when to collaborate based on the PRM feedback is key.
That seems to be the main takeaway. That adaptive integration of the general LLM's reasoning with the private SLM's domain knowledge, guided by the process reward, really works.
Did they look at any hyperparameters? Like how sensitive is it to the settings?
They did. They did some further analysis, mostly on the Qwen models. They tweaked things like the exploration constant C in the UCT algorithm.
How much it favors exploration.
Right. And they found performance peaked at intermediate values. Too little exploration, it gets stuck. Too much, it wanders randomly. Makes sense.
Standard MCTS tuning, yeah. What else?
Step length, how many tokens generated per step? Performance was fairly stable, but moderate lengths seemed best. Max MCTS iterations, more iterations helped initially, but then diminishing returns, as you'd expect.
Computational trade-off.
Yep. And importantly, the collaboration probability p-collab, the chance of choosing collaborative inference at each step.
Ah, how often do you bring in the LLM?
Again, intermediate values work best.
Yeah.
Relying purely on the SLM wasn't optimal, but involving the LLM all the time wasn't either. You need that balance.
Which reinforces the idea that the SLM sometimes is better on its own for certain steps.
Precisely. And one last thing, the expansion strategy. Expanding just one promising child node at a time in MCTS worked better than trying to expand all possible children at once.
Probably manages the search complexity better.
Seems likely.
Okay, so taking all this together, what are the real-world implications? Who benefits from GBoost?
Well, I think it's really promising for any organization that has, limited compute resources.
Which is most organizations.
Oh, yeah, fair point.
Yeah.
And especially those dealing with sensitive private data, they can't just send off to a cloud API. GBoost offers a path to significantly upgrade the performance of their existing domain-specific SLMs without the massive cost or privacy issues of relying entirely on huge external models.
So you could get better reasoning on, say, an edge device.
Exactly. Imagine needing complex analysis done locally, maybe analyzing sensor data on-site or processing medical records within a hospital network. GBoost could potentially allow an SLM running locally to tap into the reasoning power of a larger model, maybe running elsewhere, or even a slightly larger local model, selectively and efficiently.
Keeping most of the work and the sensitive data on the edge, but getting a reasoning boost when needed.
That's the potential. Edge cloud or even a slightly bigger edge collaboration, preserving privacy and managing resources.
Very cool. Okay, this naturally leads us into our novel notions segment. Where could this research go next?
All right, well, thinking about that collaboration probability, cup collab. The paper found a fixed intermediate value worked best.
Right.
But what if it wasn't fixed? What if it could be
Dynamic.
Dynamic how? What if the system learned a kind of trust score for the general LLM based on the PRM feedback?
So if the LLM's contributions tend to get low rewards from the PRM in certain situations.
Exactly. If the PRM keeps saying, nope, the LLM messed that step up for, say, questions about specific financial regulation.
Then the system could automatically lower the probability of collaborating with the LLM for future questions on that topic.
Precisely. And conversely, if the LLM consistently helps improve the reasoning score for, I don't know, creative summarization tasks, it could increase the collaboration probability there.
So a context-aware, self-tuning collaboration strategy, moving beyond a single fixed probability.
Yeah, it builds directly on their finding that fee collab matters, but makes it adaptive based on real-time performance feedback. You can imagine an LLM being great at abstract stuff, but bad at domain facts. The dynamic trust score could learn to use it appropriately.
I like that. Very adaptive. Okay, here's another thought. Building on the PRM itself.
Okay.
They used a pre-trained PRM, Math Shepherd. What about applying meta-learning to the PRM?
Meta-learning for the reward model. Tell me more.
Instead of a static PRM, could you train, or perhaps fine-tune, a PRM that learns to adapt its judgment, adapts to the specific domain, maybe even to the specific strengths and weaknesses of the SLM-LLM pair it's guiding?
A PRM that learns how to be a better judge for this specific team.
Yeah. Imagine it learning from the reward signals across different tasks during the GBoost process. It might figure out, for this SLM, logical coherence is usually the issue. Or for this LLM, factual grounding is where I need to focus.
So it could provide more tailored, more accurate feedback, potentially leading to even better optimization of the reasoning path by MCTS.
You could even envision a kind of self-improving loop, right? The collaboration strategy, MCTS plus PRM, gets better, and the guidance mechanism, the meta-PRM, gets better at guiding it based on experience.
Wow, yeah. A system that learns how to collaborate best and simultaneously learns how to judge that collaboration better over time. That's pretty advanced.
Definitely pushing the boundaries. But of course, we need the standard disclaimer here.
Right. These are just speculative ideas, food for thought, novel notions for entertainment and discussion purposes only.
Absolutely, but fun to think about.
Indeed. But stepping back, the GBoost framework itself, as presented in the paper, is a really solid practical contribution.
Yeah, it really is a significant step in making this SLM-LLM collaboration work effectively and efficiently.
It elegantly brings together that domain expertise of the SLM with the broader understanding of the LLM, using that clever process reward guidance.
And for listeners wanting a full technical story, the link to the actual paper is in the description.
Definitely worth a read if this area interests you.
So we'll leave everyone with a final thought to chew on. As AI evolves, how do we best design these hybrid systems? How do we make specialized and general intelligence truly complement each other, especially when resources are tight?
It's a huge question, and work like GBoost is giving us some really interesting answers.
Couldn't agree more. Thanks for joining us on Talk Tensors.